So what are the outputs for the input of x equals 5? So let's talk about how to do this in our calculator. Could you put every single equation into your calculator under y equals? Yeah, you could. You could type into your calculator y equals 3x minus 4, y equals 50 minus 2x squared, y equals 2 to the power of x. You could put all three of those equations into your calculator and then just go to the what? Table and find out where when x is 5, and it'll tell you what all your outputs are. Okay? It'll tell you what all of your outputs are. But I'm going to do it the math way because I know that you guys want to see it. Y equals 3 times 5 minus 4. Let's see. 3 times 5 is 15 minus 4 is 11. Y equals 50 minus 2 times 5 squared. What is 5 squared? What? Who said 10? It's 25. Zach, you're batting 1,000. 5 minus 2 times 25. What is 2 times 25? 2 quarters equals what? 50 cents. 50 minus 50 is what? 0. Last one, y equals 2 to the power of 5. For those of you that like to see what that really looks like, it's not 2 times 5, it's 2 times 2 times 2 times 2 times 2, or 32. I know I went through those quickly. Did anybody put them into their calculator? Yes? Did you put all three of them in there at one time, or you did them independently? Okay. All right, this next one. Evan is walking home from the museum. She starts 38 blocks from home and walks 2 blocks each minute. Evan's distance from home is a function of the number of minutes she's been walking. Which variable is independent? Independent is always the x variable. And which variable is dependent? So let's talk about what our variables are. Our variables are number of minutes and distance from home. So does the number of minutes that she walks depend on her distance, or does her distance depend on the time? Yeah, that one. That means that time is the independent variable. Time is the independent variable. And whenever you have an equation with time in it, time is always independent. So if you have a function of time, time is the independent variable. That's what I'm trying to tell you. The dependent variable is the distance, meaning how far she travels, or the distance depends on how long she's walking, right? Does that make sense? Okay. So the second part has a table for us. It says fill in the table below for a variety of time values. So our time values, t, which is the x thing, it's the same thing as x. So let's see. How many blocks can I walk per minute? How many blocks do I walk per minute? I walk 2 blocks per minute. When I first start, how far away am I? Yeah, I'm 38 blocks away. So it's kind of like, I'm going to draw a picture because I like pictures. Here's my house. And here's where I started from. This is 38, right? So when I first start, when time is 0, I'm 38 blocks away. After 1 minute, how far away from home am I? I'm 36. Yeah, each time for every minute, I'm subtracting 2. I'm getting 2 blocks closer. So this is 36. So what's the difference between 1 and 5? How many minutes did I walk? So I walked for 4 minutes, which means I'm going to subtract 8 because 2 times 4 is 8. 36 minus 8 is 28. And then how many minutes am I walking here? 5 minutes. And 5 times 2 is 10. So I have to subtract 10 from there. So after 10 minutes of walking, how far is Evan from her house? 18 blocks. Let's write an equation for that. Well, my beginning value, how far away am I when I started? That's my y-intercept. Good job. And my rate of change is my slope is what? Is it positive or negative? Am I adding it or am I subtracting it? I'm subtracting it. It's negative. Okay. You can also think of it as this. You can write it like this: 38 minus 2 times every minute. Okay. You don't have to put the y-intercept at the end if that helps you think about it. Okay. So the second part D or part C says, hey, write an equation for that using D as your distance and T as your time. So instead of using Y, I'm going to use a capital D. And instead of using X, I'm going to use T. So I can write it like this, or I can write it like negative 2T plus 38. Either way, whichever way works best for your brain. They both mean the same thing. Okay? Who's that with their head down? What's your name? I'm looking at my seating chart. David, is that you? Pick your head up. Do you have a pencil? Dude, what did I say yesterday? If you don't have a pencil, what should you do? Where's your paper? You lost it? Did you say, Mrs. Bischoff, I lost my note packet? Do you want another note packet? Not really? Okay, so let me explain something to you really quickly. You're not going to sit in my class with your head down. So, David, do you want another note packet? So you want to go to ALC then? Is that what you're saying to me? Because you're not going to sit in here with your head down. Or are you going to get out a piece of paper? So, again, let me make this really clear. I'm trying to help you. You understand that? So do you want another note packet? Turn around, Cole. He doesn't need you to look at him. I'll give you another note packet. I don't have a problem with that. Would you like another note packet? Perfect. All right. Determine the number of minutes T that it takes for Evan to reach home. How long is it going to take him to get home? 19 minutes. Explain how you did that. Yeah. 38 divided by 2 is 19.
That's a D.
Yep, D. Yes, Jan. David maybe? David's last name, I think, is his last name. I'll double check. Is on his way down. He actually just walked out like a minute ago. Okay. I am. Okay. Thank you, dear. Bye-bye. Okay. All right. So yeah, we just took the number of minutes. If we're getting home, that just means that our distance is 0. I want to show you what that looks like mathematically, right? So we just let our distance equal 0. If I were to solve this, subtract 38 from both sides. Parker's thinking is 100% correct. First of all, yes, you just take 38 and divide it by 2. I'm just trying to show you mathematically, okay? Divide both sides by negative 2. 19 equals the time. Okay, so that's the math answer. It would take 19 minutes from when he started or she started to get all the way home. All right, let's go to this average rate of change. Let's talk about average rate of change. So this was also part of yesterday's lesson. So we are a little bit behind, and I apologize. I'm not going to cram in 2 whole days of lesson because I know that would be awful. So we should be about right here. Is that what you guys see when you turn the page? Okay, cool. So average rate of change. I don't know why, but whenever you guys see the word average rate of change, you automatically I think it's the word intervals, over an interval, that throws you off. But average rate of change, does anyone see anything familiar about any of those equations up there or formulas? Does anyone know what average rate of change really means? Well, what if I were to put this in front of it? What did I just draw on the board? An M. What does the little m mean in terms of equations in math, typically?
Motion.
No, y equals m times x plus b. What does m stand for? Slope. Yeah. So really, the average rate of change is another way of saying slope. And when we're looking for it in a word problem, we're typically looking for the word per. Why would it show up as average rate of change instead of slope? Because we're trying to confuse you, honestly. That's really I mean, I believe that. I struggled with math when I was younger. Whoever is writing these problems is just trying to confuse you, okay? Average rate of change is just slope. Don't think of it as any other thing except just slope, all right? So let's talk about this function right here. We're going to take the function f of x equals x squared plus 5. And I need to know what the rate of change is, or the slope is, from -1 less than or equal to x less than or equal to 5. That just means let x equal -1 and tell me what y equals. And then let x equal 5 and tell me what y equals. Well, the easiest way to do that is with your calculator. Yeah. And actually just go to the y equals. So I want everyone to go to the y equals, press y equals on their calculator. It's the little gray button at the top. Y equals, and you're going to put in x squared plus 5. You're just going to put in x squared plus 5. If you don't know where the squared is, holler at me and I'll show you. If you don't know where the x is, holler at me and I'll show you. If you can't find y equals, once you put in y equals x squared, thank you so much, x squared plus 5, I want you to go to your table. Go to your table. So y equals right here. X is this button right here. I always use my caret function. So x caret 2, and then arrow over plus 5. So how do I get to the table from here? We talked about it yesterday. Second graph. Second graph. So I need to find out what the output is, what y equals when x is -1. So on your table, find -1 for x.
6.
Second table. So when x is -1, what's your output? Can you see that? Yeah, it's 6. Good job. And what about when x is 5? All righty. So when x is -1, y is 6. When x is 5, y is 30. Does everybody see how to let your calculator do that? So you're only putting the equation in one time. Okay. So now we're finding the slope. Remember that the slope is the change in y, 30 minus 6, over the change in x, 5 minus -1. What's 30 minus 6? 24. What's 5 minus a -1? And you can put it into your calculator just like that. Or remember that minus a negative means plus. 5 plus 1 is? So what does that turn out to be? 24 over 6 is 4. So this 30 minus 6, 5 minus a -1, that's the slope formula. I actually like looking at it as a table of values. If you've had me in class before, this is typically how I write it. I say to myself, 20 or 6 plus what equals 30? Well, 6 plus 24 equals 30. And then I say negative 1 plus what equals 5. Negative 1 plus 6. And I still get the same answer, 24 over 6. It's still, you're still finding the difference or the change. I want you to use whatever method works best for you. Okay? But that's what the average rate of change is. It's just your slope. Average rate of change is just your slope. Okay? All right. So we're going to do the same thing, same function. Oh my gosh. So do we need to put the function into our calculator again? No, we just need to look at when x is negative 6, what is my output? What is y? 41. When x is positive 4, say it again. 21. Okay. So what did I do to 41 to make it equal 21? Did I add or subtract? I subtracted. How much did I take away? 40 minus what equals 41 minus what equals 21? Minus 20. What did I add to negative 6 to make it equal positive 4? Well, negative 6 to 0 means I add 6, and then 0 to 4 is 4. So what's 6 plus 4? 10. My change in y over my change in x is negative 2. So when you have a question that gives you a function and a couple of different intervals, use your table and your y equals in your calculator so you're not just killing yourself with math, okay? Let's work smarter, not harder, right? Let's make it as easy as possible. Can you do this in Desmos? Yeah, okay. So the next one I'm going to do in Desmos just because, well, I can't because it doesn't give me a, I'll do this one in Desmos just because I want you guys to see if you don't have a graphing calculator at home that you can do it in Desmos, okay? So let's look at this one, exercise number 6. Did anybody need to see this again? Everybody good with this? Okay. So number 6 says the function h of x is given in the table below. Which of the following gives the average rate of change, which means which of the following shows the slope over the interval of 2 and 6? So I wrote myself a note and I put change. The 6 isn't even in our table. Change this to a 4. So I really want it to say 2 is less than or equal to x is less than or equal to 4. So that's the first thing that we're going to do. Change that. Okay. So that means when x equals 2, what is my output? 9. And when x equals 4, what is my output? So we're just comparing those. What did I do to 9 to make it equal 6? Minus 3. What did I do to 2 to make it equal 4? Add 2. So my rate of change or my slope is negative 3 over 2. What answer choice is that? Yeah, it's answer choice 1. It's answer choice 1. If I gave you filled out notes yesterday, you still have these. This is still yesterday's lesson, okay? This is still yesterday's lesson. Example number 7, I'm going to do using Desmos because I want you to see that you can use Desmos to solve something like this, right? So if you don't have a graphing calculator at home, use Desmos graphing because you want to make it easy for yourself, right? I don't want you guys to think that this is hard because it's not. Everybody good with this so I can move on? Anybody need it for longer? Okay, so I'm going to type in the equation in Desmos just so it's already ready to go. And then hopefully you guys can tell me how to get the table. So our next example is the function g of x, or g of t, sorry, equals t squared plus 4 divided by 2. And we're looking for the interval between 2 and 8 minutes. So that's the same thing as saying, if you're typing it in, you're going to find out what happens when x is 2, and you're going to have to find out what happens when x is 8, right? You're trying to find the output when you input a 2 or you input an 8. So I'm going to go to Desmos, and I'm going to put that equation in there for us. And I used y instead of g of t, and I used x instead of t. But this is exactly what that equation was. This is exactly what that equation was. I want a table. How do I get a table from Desmos? If you had me at all, you should know.
Doesn't it show like on the top left or right? The gear.
Hit the gear. And it says edit your list. Click that. Yeah. And bam, there's your table. Okay. What values are we finding? X is 2 and X is 8. If you don't have an 8 as an input, you just type it and it'll tell you what your output is. Let your calculator or Desmos do the work for you, right? So what did I do to the 4 to make it equal 32? Sorry, what did I do to the 4 to make it equal 34? Plus 30. What did I do to the 2 to make it equal 8? Plus 6. So I get 30. I get 30 over 6, which equals 5. So this models the number of glasses she sells each hour. So this is our slope or our rate of change. She's selling 5 glasses per hour. 5 glasses per hour. 1, 2, 3. Okay. So here's what we're going to do. We're going to do one more page, key features. We're just going to do the first page of this next lesson, and then we're going to stop. Okay. Because I want you guys to get into Desmos and have time to do some work. Is everybody good with this so far? Does everyone feel like they can either put a y equals function into their calculator, or they can put it in Desmos and get a table? You feel confident about that? Okay. So use that tool, right? That's why we have that. Math 2 is so different than Math 1 because we always are encouraging you. Use a calculator, use your graphing calculator, use your tools, okay? So this is kind of where I jumbled us up yesterday because I went to the wrong spot. So let me find the right spot. I don't even know where the right spot is.
Sorry.
How about right here? This is where I want you to be. Okay, so let's turn the page. Is this your next page? This is my next page. Okay, good. All right. So given the graph of the linear function, g of x equals 1/2 x plus 1, do the following. Or not given the graph, given the linear function, g of x equals 1/2 x plus 1, do the following. Create a table of values. And it says it's a limited table. Like you only need 3 or 4 points, right? So how could you do that? How could you create a table of values that represents this function? You could start at 1. Let x equal 1. Sure. What else could you do? Are we going to plug all these numbers in to our calculator? Yeah, so you're just going to keep writing like 1/2 times 1 plus 1, 1/2 times 2 plus 1. Can I offer a suggestion? When you take half of 1, do you get a fraction or a whole number? You get a fraction. So since our slope, since the number we're multiplying by is 1/2, what kind of x value should we pick? Say again.
What do you need?
Yeah. So I don't want to have to graph decimals. I only want to graph whole numbers. How about if I choose even numbers? Because all even numbers are divisible by 2, and multiplying by 1/2 is the same thing as dividing by 2. Does that make sense? Yes or no?
Yes.
Okay. So I'm going to choose -2 to start with. And I'm going to turn this 1 into a big fat 0. +2 And then I'm going to turn this, actually, I'm going to turn it into an 8. Okay. So I'm going to take this equation right here, and I'm going to rewrite it as y instead of g of x. And I'm just going to put it into my calculator and go to the what? Y equals, so everybody do that in their calculator. Y equals, clear out your last equation. How do I put 1/2 into my calculator? How do I show that mathematically? 1 divided by 2 x plus 1. I want to, what do I need next? Do I want a graph or do I want a table? Second graph. Yeah, second graph. So what is the output when x is -2? 0. What is the output when x is 0? What is the output when x is 2? And what is the output when x is 8? Good job. So let's just graph those. That's a limited table. So when x is -1, 2, y is 0. When x is 0, y is 1. When x is 1, 2, y is 2. And when x is 1, 2, 3, 4, 5, 6, 7, 8 off my graph, I go all the way up to 5. Something like that. It's a sketch. It doesn't have to be perfect, right? It's a sketch. It doesn't have to be perfect. So it says create the graph. We did it. We created the graph. Tell me what the slope of the function is graphically. Illustrate it graphically. Well, that just means show me how much I go up and how much I go over. So I go up 2 over 4. Well, 2 over 4 is the same thing as 1/2, which is the same thing as our function. It says circle the y-intercept on your graph. That's right here. This is key features. This review is key features of graphs. So let's just talk about it. If I have a linear function, that's what that straight line is, right? If I have a linear function, I should be able to identify my slope. I should be able to identify my y-intercept. That's a key feature. And I should also be able to identify my x-intercept. Okay? So when it says key features for a linear function, that's what it's looking for. Slope, y-intercept, x-intercept. What is the slope of this function? 1/2. What is the y-intercept? 1. Crosses the y-axis at 1. What is the x-intercept? -2. Okay. Do you guys feel okay with those 3 ideas? From a straight line. This is a linear function, so it's going to give us a straight line. Okay. All right. Our next function is not linear. Our next function is not linear. Okay. What kind of a graph is that? It's a parabola. Who said that? Good job. Draco, right? It's a parabola. We know that, I think that we talked about this yesterday. Parabolas come from what kind of functions? Quadratic. Who said that? Good job. It's quadratic. Trishawn said quadratic. So this is a quadratic function. That means that x is squared. So it says find the value of the following, f of 4. What does that mean? It just means let x equal what? Yeah, let x equal 4. So let's go to our graph. And when x is 1, 2, 3, 4, where do I touch the line, the graph? Count over. When x is 1, 2, 3, 4, what is my y value? It's 1. What about when x is -1? When x is -1, go up to your graph. What is y? It's 6. Okay. Let's talk about some key features on this graph really fast. What is this point right here? That's my y-intercept. I'm going to just draw an arrow and I'm going to write y-intercept. Okay. What is this point right here? It's the vertex. It's the vertex. Yesterday, David told us that the vertex was the turning point, and he's absolutely right. I know he's not in here right now, but the turning point is where the graph changes direction. So what part of the graph, Amaya, is the graph increasing? Or what part of the graph is decreasing? Do you guys remember hearing those terms? Increasing and decreasing is talking about the slope. When is the graph having positive slope and when is it having negative slope? So if that vertex is the turning point, then that vertex is the place where the direction changes. So I'm going to draw a little dashed line right here. I just want to remind you guys about what you know from Math 1. This line is called the axis. Good job. Axis of symmetry. This is my axis of symmetry. So think about everything that happens before the axis of symmetry is going to be different than everything that happens after the axis of symmetry, because the axis of symmetry goes right through the turning point. So I want you to look at the line, the graph, the curve before the axis of symmetry on the left-hand side. Does that part of the line show positive or negative slope? Yeah, this is negative slope right here. That means that it is decreasing. That means that this part is decreasing. So I'm just going to abbreviate DECR. It's decreasing. DECR. So if everything that happens before the axis of symmetry and everything that happens after is different, that means that this part of the line has positive slope or is increasing. This part is increasing. I'm going to abbreviate that INCR, increasing. Okay. And then I want to talk about your vertex, because if your vertex is your turning point, it has what?
That's your minimum.
Yeah, it's your minimum value. It's the lowest point on the graph. It's the lowest point on the graph. So your vertex is your minimum, and it means all of the y values are greater than or equal to that point right there. Okay? All of the y values are greater than or equal to that point right there. We ask sometimes what the ordered pairs are for like your vertex. So I want to talk about that really fast. What is the ordered pair of the vertex? This is the point what? What ordered pair is that? We say the x1 first. So it'd be 2, -3, yes. So that means that this graph is decreasing for all x values that are less than 2. And that's everything that's on the yellow side. And it's increasing for all x values that are greater than 2. That's what that tells you in terms of increase and decreasing. And then it tells you that it has a minimum of, your minimum is always, your minimum or your maximum is your y value. So what's the y value of that vertex? Look at your vertex. What's your y value? It's -3. So this has a minimum of -3. This is everything that you can tell about the graph just from the vertex. You can get all of this information just from the vertex. Okay, we're almost done. So let's go to this question. It says, what values of x give you f of x equals -2? This is the same thing as saying y equals -2. So I'm going to just graph that line. Y equals -2 is a horizontal line. And I'm going to graph that so you can see it. Where does y equals -2 touch the graph? What are the x values?
Positive 3, -2.
Yeah. X equals +3. Let me see how to do that. Right here. This is y. This is all y equals -2. This whole line right here. Do you guys see that? Y equals -2 when x is positive 1, 2, 3, and when x is positive 1. Do you see that? When x equals 1, you get an output of -2, and when x equals 3, you get an output of -2. That's what that's asking you. The last question says state the minimum or the maximum, and Parker told us that we had a minimum of -3. This graph opens up. That means that A is positive, and you're going to have a minimum. I remember that A is positive because this looks like a smile. If A is negative, your leading coefficient, your graph is going to be what? Sad. It's going to frown, and that means that you have a maximum. Your high point, your vertex is going to be a maximum, where this vertex is a minimum. A lot of information in 2 pages of notes. A lot of information in 2 pages of notes. We're going to stop there. Okay, and I'm going to go back